Hi guys, this is a video to help you understand the word the system in science. So people use the word system a lot in regular life, so I'm sure you've heard it used. Sometimes we talk about systems in any class, a computer class, um, even an English class, you might talk about a system because you're reading about one. Um, there's in social studies all kinds of social systems and government systems. But I want to define this thermodynamically speaking. When I say the system and I'm thinking in science, it always makes me think of like the matrix, like it's part of this bigger thing that we're all a part of. And in a lot of ways, depending on how you define a system, it is kind of like that. So here's some examples of systems in regular life. There's the solar system, the nervous system, a sprinkler system. These are all operating systems. So we've got Windows, Apple, Android. And I don't know if any of you know what this one is, but if you do, it means that you're probably a super nerd like me. This is the Linux operating system. I don't have a Linux device, but I know what it is. So I'm not like the nerdiest of nerds on the spectrum, but I'm pretty close because I know what it is. And then we have, of course, the digestive system. And actually, all of these uses of the word are referring to a system in a scientific way, but we have to really make sure that we figure out what do all of these systems have in common. Or if we know how to look at the solar system in terms of thermodynamics as a system, well, how does that compare? How is that similar and different to the Windows operating system? So this is like a model, okay? So not like a Tyra Banks model, but in science, when something is pretty complicated, we usually break it down into a model. And it could be like a physical model. Like I have a cool cell model in my classroom that has like all the organelles or these little pieces, and you can put it together. But sometimes a model is just a picture or just a sentence that's about your more complicated thing, but it breaks it down into the most basic parts. So the most basic parts of any system are the system itself, the boundary of that system, so like the edges of it, and the surroundings. So I'm going to ask you a question about these things right now. But if I were you, I would write this down, draw this model on some piece of paper that you have, because I will refer to the system a lot in the future, and I'll ask you to define systems, but I'm not going to go over the definition every time, so you might want to keep this in your notes. So the system, the definition of system is the thing you are studying. And I know that's not a very scientific definition, especially using the word thing, but it's true. The thing you're studying is the system. So sometimes you might be studying something like absolutely tiny, like one cell. Sometimes you might be studying the universe's systems, and then that would be really, really huge. So it really is the thing that you're studying, the object of your study. The boundary is the edges of the system. So where does that system end? Whenever you're studying something, you have to decide like where to end it, because otherwise if you started with a cell, you'd end up studying the whole entire universe, because you could just keep going and going and going and seeing what part of it is connected to the stars. And so it would just keep growing and it would get out of control. So we need to put edges on our systems. That's what the boundary is. And then the surroundings, I love this because it's just what it says, is everything that's around your system. It's what surrounds it. So if we were studying a cell and it was in your blood, then the surroundings of that cell would be like the rest of your blood and your plasma and your body. Usually you don't have to study the whole surroundings, because technically if you're studying a cell, the surroundings is like, you know, the whole entire universe, but you might, just do the local surroundings, so it's close to it. Okay, there's three types of systems, and we define the systems by whether or not matter and energy can get into and out of them. So remember from our last class about the universe, we learned that matter is anything that has mass and volume. So it has to have atoms in it. That's what mass means. And it has to take up space. And then energy is different, although it's kind of the same because you can exchange matter and energy. But energy is the ability to do work. And so that would be like waves of heat would count as energy. Light would count as energy. So when we look here, the three types of systems, and I would draw this diagram too because it's pretty easy to draw. This is another model, so it's just breaking it down to the basics. An isolated system is one where matter and energy can't get in or out, so it's totally alone. You can't get anything into or out of it. This is only a theoretical type of system. In real life, we have not figured out how to make a system that energy can't get through. The closest example would be like a thermos. You know, you try to trap the heat inside of the thermos, but we can't do it with like 100% of the energy trapped inside and outside. So it can still cross the boundary. In a closed system, and I know this is weird because it's called closed. I wish we would call it something else. Matter can't get through, but energy can. So energy can cross the boundaries of that system if it's closed, but matter cannot. And then an open system is where both matter and energy can cross the boundaries from the surroundings into the system and from the system into the surroundings. Definitely make sure you understand those three differences. Okay, let's do a couple of case studies here, some practice. All right, so Chadwick Boseman's been in the news lately because he passed away. He had cancer. He's our awesome Black Panther actor. But if we know he died of cancer, and if we were his doctor, how would we define the system of Chadwick Boseman? What would be the boundary of him? What would be the surroundings? So of course, he would have the boundary would be like his skin, right? The surroundings would be the air around him. I guess you could count his clothes as surroundings. What do we think? Is Chadwick Boseman going to be an open, closed, or isolated system? Remember, we can basically always get rid of isolated. Now we just have to decide if matter and energy, or one or the other, can get in and out of Chadwick Boseman. All right, well, we know that he was eating, so matter was going into him, and he can give off heat. Like if you shook his hand, it would be warm. So he is an open system, just as every single person is an open system. Matter and energy go into and out of us. Here's another one. Your cell phone. Okay, so your cell phone is a type of system. So think for a second, how would you define the boundaries of it? How would you define the surroundings of it? And what type of system is it? Here, I think you could argue that it's an open system because you can like take a battery in and out of it. Like you could exchange the battery or any of the parts. But really when a cell phone is operating the way it's supposed to, it's kind of a closed system where only energy goes into and out of it, right? Energy comes in the form of light off the screen. You plug it in and you put energy in it from like your electrical grid. So energy is definitely passing the boundaries. But I think you'd have to make a kind of bizarre argument to say that matter does. All right, now the Earth. Okay, remember this photograph? It's called Earthrise. What is the system of the Earth? What do you think would be the edges of the Earth, the boundaries? I think it would be the atmosphere, right? The outer atmosphere, the cushion of air around our planet. The surroundings would be the solar system. And what type of system is it? Is matter and energy going into and out of the Earth? Energy for sure, right? There's the sun. But what about matter? We've sent satellites out of it. We have meteoroids that come and hit the ground on Earth. They turn into meteorites once they're in our atmosphere. So I would say it's an open system. All right, guys, that was all.